Imagine winds moving at more than 200 kilometers per hour, seawater rising like a wall, buildings shaking, and within a few hours, entire coastal region changes forever. That is the power of a cyclone. Good morning, everyone. This is Dr. T. Naresh Kumar. Welcome back to our channel. Today, we are going to understand cyclones and their impact, one of the most important topics in disaster management. Let us see the contents of that one. We have cyclones and their impact, climate change and its impact on tropical cyclones, nature of cyclonic wind, velocities and pressure, and cyclone effects, storm surges, floods and landslides, behavior of structures in fast cyclone and windstorms. We'll study about the case studies for major cyclones and cyclonic retrofitting and strengthening of structures, then adaptive sustainable reconstruction, then last but not least, lifeline structures, that is like temporary cyclone shelters, we are going to discuss. We'll see one by one. Let us see what is a tropical cyclone. A tropical cyclone is a large rotating storm system that forms over warm ocean water. It is characterized by low pressure at the center, strong rotating winds, heavy rainfall, storm surge near coastal areas. At the center of the cyclone, we have the eye, calm and clear. Surrounding the eye in the wall, where the maximum wind speed and damage also occur. If you see the figure of this one, this is the cyclone view from the satellite, and we have a eye in the center and eye walls will be at the side of this one, and you can see another one. This is the eye at the center, these are the eye walls which are there. And the nature and formation of tropical cyclones are sufficiently warm sea surface temperatures above 26 to 27 degrees centigrade will be there, and atmospheric instability and high humidity in the lower to middle level of the troposphere. Then presence of pre-existing low level disturbance and low vertical wind shear, and a fully developed cyclone features a funnel-like structure with a calm center called the eye. This was the eye. A surrounding eye wall, where these are the eye walls which are there, with the strong winds and outer spiral rain bands which are there. When you see the cross section of this one, you will have this kind of things, and the cyclonic structure will be like this. At the center we have eye, and beside of the eye walls will be there, and spiral rain bands will be there throughout this one. And this is another cross section of the storm. Eye will be at the center, and flow of dry air from the uppermost keep the eye free of clouds will be there, and height of this cyclone will be almost 13 kilometers, and direction of movement it will be like 16 to 24 kilometers per hour. So this was the and ocean temperature will be almost 26 to 27 degrees will be maintained at that point to develop a cyclone also. And this is another cross section of a cyclone. If you see this one, this we have the eye, and this is the eye wall. Outer flow cloud shield will be there, and spiral rain bands will be below of this one. Outer flow cloud shield below it will be the spiral rain bands will be there, and we have both sides. And this is the cross section of this one, and you can see the top view of this one, where the center of eye will be there. Here this is the eye wall, and these are the rain bands which are there. So this is another cross section. You can see this is the topmost outer flow cloud shield will be there at the top of this one, and where the clockwise winds will be there, and descending air will be going inside also, and these are the spiral winds which are there, and rotation of cyclone will be there here also. And one more figure, it can be like this. This is the citrus cloud or central dense overcast cloud will be there. Total it will be covered like an umbrella, and these are the rain bands which are there. These are the, so light and heavy rainfall will be there. By seeing the yellow color, these are the light rainfall will be there, whereas at the bottom it will be having heavy rainfall will be there. And whereas this at the top of this one, this is the cool air which is covered at the top, and warm air at the bottom will be there. So this is another one classification of cyclone. So we can see all the cross sections, and this is divided into 4 types or 5 types of categories. When you talk about like category 1, the wind speed will be almost 119 to 153 kilometer per hour. It will be like a minimal or some damage to trees and mobile homes. And category 2, it is like 154 to 177 kilometer per hour. It will be like moderate, and where damage of trees, uprooting of trees will be there. And category 3, it is like 178 to 208. It is like extensive, where structural damage to buildings also it will be occurred. Category 4, it is 209 to 251 kilometer per hour, which will be like extreme, where severe structural damage in the coastal flooding. And last but not least, like category 5, it is like 252 plus kilometer per hour. It is catastrophic, and complete roof failures. Then total destruction will be occurred for this. Extreme destruction will be there for this. When you see the sea surface temperature, it will be like anomaly. It is like showing this one, and we'll have some more figures like this. This is like surface air temperature anomaly in 2025, where warmer will be like very this one, and very cooler areas it will be here. It will be there like blue color things will be like cooler temperature will be there, and where the white color it will be like 0 to 0.2 to 0.5 will be there. So this is another temperature view, which is like sea surface temperature, which is anomaly, which is taken from 1982 to 2010 up to that. But this photograph was taken in 31st March 2020. So this is another water temperature anomalies from the weather department, weather authority main development region, which is there. So this is one more thing, and this is the tropical Pacific surface temperature anomalies, which is like Australia. Beside of this one, we have big oceans which are there. So there also the temperature will be like 2.25 will be there, the difference of average temperatures. And whereas here we'll have like minus 2.25, where very cool temperature will be there. From November 14 to January 15, it is the temperature which I have taken. Whereas here this photograph, it is like to November 19 to 2020 January. This was the photograph which is taken. That is the difference of tropical Pacific Sea surface temperatures. And whereas tropical Pacific outgoing long wave radiations of anomalies which are there, like difference from average wind will be like this is the thing, and minus 30 to almost 30 plus temperature will be there, like November 14 to 2015 to November 19 to 2020. These are the two photographs which can be shown beautifully. And these are the 1970 before and after flood which is occurred. And this is another slide which is shown very clearly for this one, and the coastal regions where the before flood and in 1970, once the flood was occurred in 2020, total was covered with the things. And here you can see the future projections which are there. And when you see about the climate change and its impact on cyclones, there are like increased intensity will be there. Then second one, sea level rise will be there. Ecosystem fragility will be there. Unpredictability will be there. So here these are the climate changes which can be taken into picture. And these are the flooding maps which can be seen by the mechanism of multiples. So coastal flooding storm and riverized flooding, urban flooding, island fresh flooding will be there. And this is one more beautiful photograph which is shown for the thing, for the storm. And these are the landslides which can be seen where the damage will be occurred for this one. So you can see land risk factors which are affected, where the hilly areas and valley places which we can see steep slopes will be there, including like an inclination of 15 degrees. Totally it will be like increase of risk will be there, and soil saturation will be there, and deforestation also it will be occurred, one aspect it will be there, and also geological conditions, then human development which is there for that also, and the previous instability of the soil also it will be occurred. So there are some types of cyclone induced mass movements. One is debris flow will be there, then landslides will be there, multi-slides also it will be there, and rock falls also it will be there for that. So this is understanding the compound impacts which are there like this. And this is one more thing, like nature of a cyclonic wind and velocities of the pressure. So whereas northern hemisphere will have the anti-clockwise movements of air will be there, whereas in the clockwise movement will have like on the southern hemisphere. So both the two things will be there. So there the eye will be there, the eye wall and the spiral rain bands will be there, where the eye will have the calm central part with the lowest pressure and highest temperature, usually ranging from 20 to 30 kilometer in radius, and the eye wall, a ring surrounding the eye containing the most powerful winds and deep connections. Then when you see about the spiral rain bands, the outer part of the storm, which can be hundreds of kilometers long also, this longest part. And wind velocities also, it will be like outer wind velocity distribution also you can see here. The speed of wind speed in a cyclone, outer rain bands it is like 50 to 100 kilometers per hour. Then inner rain bands it will be like 100 to 150 kilometers. So eye wall it will be like 150 to 300 kilometers per hour, where eye will have like 10 to 30 kilometers per hour. So this is the way of things that are the velocity that are distributed, and and this is the atmospheric pressure dynamics which are there. We can see the hurricane fluid and longitudinal section of this one, and this is the pressure range we have seen just now into category 5 up to like this, and wind loading structures also we can see. Then these are the important considerations we should take out of dynamic effects, pressure differential and debris impact, and durations also we should take it. Then when you see about the cyclonic effects, the principal threats from a cyclone are gale and strong winds, torrential rains and storm surges. These are called the cyclonic effects. So in this we'll have like infrastructure damage, then socio-economic impact will be there, health hazard also it will be there. So when you talk about like infrastructure damage, high wind destroy houses like thatched and kucha structures, power grids also it will be get damaged, and communication towers, tuning loose debris into lethal flying objects also. Then when you see about the socio-economic impacts, cyclones run standing crops, kill livestock and deposit salt and agricultural land, increasing salinity and causing flood storage also. Then seeing health hazards also, standing water and the destruction of sanitation system lead to outbreaks of diseases such as malaria, cholera and viral infections. So when you see the stagnator of water will have so much of diseases, more of the stagnated water will have more diseases also, like malaria, cholera and viral infections will be there. Now when you see about the storm surges, where the total water which will be like almost 17 to 20 feet water it comes to the coastal areas, and total area will be flooded. The storm surge is an abnormal rise in sea level accompanying a cyclone produced primarily by the cyclone winds pushing water towards the shore. Storm surges are responsible for approximately 90% of cyclone related deaths globally. So this is one more thing. The mechanism you should understand, the reduced pressure of the cyclone core sucks the water upwards while the strong winds pile the water up against the coast. So impact also it should be there. This results the sudden coastal inundant, this one. inundation, where sea water can flow up to 40 kilometers. This water will go up to 40 kilometers inland, destroy buildings and eroding beaches also. This will be like this, the total demolition of this one. And floods also we should see. So the floods is a overflow of water onto the land that is normally dry. Cyclones are major cause of flooding due to their associated heavy and prolonged rainfall. And landslides also which is there, which we have been discussed previously slide. And this is one more beautiful topic. It is like a behavior of structures in past cyclone and windstorms. So here, the behavior, you should understand the structural failures which are there. Once we will discuss about the behavior of structural failures. The behavior of structure during cyclones and windstorms is a critical field of study, as these events frequently cause extensive damage to both engineered and non-engineered infrastructure. Past disasters shows that physical damage is often measured by casualties and the destruction of residual, commercial and critical infrastructure such as power, grids, roads and communication networks. So this is one more thing. So common structural failures which we can see like roof failures, failure mechanisms like uplift forces which are there. Then this is the roof shielding failures which are there, masonry wall failures and window and frame failures which are there, foundation failures. This is also called as progressive failures you can say. And when you see this another figure which is there, the very first one it is like roof failure which is there, wall failure and window failures which are there, and foundation failures you can see it at the bottom, all the columns are destroyed. So residential damage, infrastructural failures, then third one is foundation and erosions. First is rooftop also is there. Now when you see about the case studies, we have a few more case studies which are like show the case studies related to this. So very first one, cyclone Naji and Nargis in Myanmar 2008. It was occurred in May 2nd to 3rd 2008. So which is also called as Burma. So almost intensity of this one cyclone is category 4. It is like 215 kilometer per hour. The casualties is almost 1,38,366. Deaths were occurred at the time, making it the deadliest cyclone of the 21st century. The total economic impact is almost $10 billion in damage. So the key impacts is like storm surges reached almost 3.5 to 5 meters, inundate the low-lying deltaic region, and almost 95% of buildings in some coastal and completely destroyed. So this is one case study you can see. This is the way the total cyclone was covered all the residential houses with flood. And this is one more aerial view of the cyclone which is covered total things in the Burma. And the second one, Hurricane Katrina, which is occurred in USA 2005, where in August 23 to 20 up to 30 2005 it was occurred, where this was the destruction before destruction, and it is after total flood was covered throughout the things. And it is almost a Gulf Coast USA, especially Louisiana, New Hurricane and Mississippi. Total intensity is category 5 at peak, category 3 at landfill and landfall. Then casualties 1,833 deaths. Economic impact almost $125 billion coastal natural disaster in US history. So the key impact from that is storm surge reached almost 8.5 meters along Mississippi coast, and a catastrophic failure of the level system in new hurricanes, almost 53 different breaches, 80% of new hurricanes flooded, some areas under 6 meters of water, 1.5 million people evacuated from regions. Total destruction of the communities along the Mississippi coast is waveland by base to. And this is another case study which is there. You can see the case study. Here, this is the cyclonic case study. It is like a third one, Kerala flood 2018, which is done almost primary and hydrological disaster, which is occurred for the event Kerala 2018 Kerala event, illustrated the fragility of modern infrastructure to high water event. Okay, in this we can see almost critical infrastructure which are there. Then protective buffers also we have seen. These are the protective buffers which can be done, and these all are the case studies which are done. And cyclonic retrofitting, it is one more beautiful topic which is should be covered in this. So here, the cyclonic retrofitting is nothing but once the retrofitting refers to the reinforcement and upgrading of existing structures to make them more resistant and resilient to the damaging effects of high velocity winds and storm related hazards. The structural mitigation approach aims to reduce physical and